Hello students, welcome to the course of Automotive Manufacturing Processes and Technology. Myself Vimal Salot from LJ Institute of Engineering and Technology. In this session, we will discuss about metal melting furnaces. We know that in case of casting process, molten metal is poured inside the mold cavity. After completion of pouring, it is allowed to solidify, and the solidified piece is known as a casting. Now, purpose of furnace is to melt the metal. According to method of melting, all furnaces can be broadly classified in two categories, that is furnaces for batch melting. In this type of furnaces, it is used for melting of small quantity of metal. So varieties of metal, if they require to melt in a small quantity, then this type of furnaces are used. It includes crucible furnace, open earth furnace and electrical furnace. In case of crucible furnace, the fuel used is a coal, and in case of electrical furnaces, the heat is obtained by the electrical resistance. Another type of furnaces is furnace for continuous melting, where the capacity of furnace is large, so large quantity of metal is melted and it is a continuous operation. So in that category, the furnace used is known as cupola furnace. We will see in detail about crucible furnace. There are two types, that is peat furnace and another is gas fired or oil fired furnace. So let us see peat furnace. The fuel used in peat furnace is a coal. It is simplest type furnace among all the categories of furnaces. So it is generally mounted in a pit. That's why it is known as a peat furnace. Outer lining is made from the refractory material. So it consists of a crucible. Here in this diagram you can see it is a crucible. It is made from the fire clay. Surrounded to this crucible, coal is fed, and purpose of coal is a combustion process to produce the heat. Here chimney is used to produce a natural draft. As height of chimney is more, it will produce negative pressure, and because of that negative pressure, the air will be sucked inside this furnace and it will be used for the combustion purpose. So here it is a crucible and it is surrounded by this coal. When coal is ignited, combustion takes place and it will produce high heat which is sufficient to melt the metal. Here the quantity of metal is small quantity, but varieties of metal can be melted. Next type is oil and gas fired furnaces. So the fuel used for combustion purpose, it may be oil or gas. So here it is a mixture of gas and air. Oxygen from the air is useful for the combustion process. So fuel used is gas plus air, and it is a crucible which is placed inside this furnace. Outside of this furnace, it means the shell of this furnace is made from the refractory material. The crucible is placed over the pad which is at the bottom of the furnace. Gas and air is supplied by the blower to this furnace area, and it will surround the crucible and then it will move in upward direction. So exhaust gases will be removed from this direction, and in this way the metal is melted. Next type of furnace is a cupola furnace. Cupola furnace is very widely used to melt the cast iron. So Scrap material and pig iron is melted in the cupola furnace in a large quantity, and we can obtain cast iron as a end product. So in first stage we will see the construction of cupola furnace. So cupola furnace is made from a boiler plate of approximate 6 mm thickness. So this outermost part is known as a shell. It is shell of the furnace and it is of cylindrical type, and it is open at both the ends, at upper end and at lower end. Inside the shell, refractory lining is made, which can be made from the fire bricks. Foundation of this furnace is shown here. It is supported by the cast iron legs on the foundation. Bottom door, the bottom part of this furnace is closed by this bottom door, but it is flexible in the sense that we can open this door and it may be of drop down type door. So when the operation of melting is completed, this door can be dropped down and we can obtain the molten metal. Tuyeres are shown here. The purpose of tuyeres is to distribute the air inside the shell of a furnace. So it is one type of nozzle which is useful to supply the air, and the oxygen from the air is necessary for the combustion purpose. So it will work like nozzles, and as it is a nozzle type, it will provide the air inside the furnace with high velocity. Wind box. This part is known as a wind box, which is surrounded to the furnace, and at the wind box this air blast pipe is used. So with the help of the blower, air is blasted and that air is supplied with the help of the tuyeres inside the furnace. Charging door. So it is a charging floor, and above charging floor charging doors are located. These doors are used to charge the cupola furnace. So from this door the alternate layer of metal, flux and core will be charged inside the furnace. Tap hole is located here at the bottom part of this furnace. The molten metal can be collected from this part, which is known as a tapping hole. Slag hole is located here at this side of this furnace. The purpose of slag hole is to remove the slag from the molten metal. As molten metal may contain some impurities, those impurities are lighter in weight, and with the reaction with this flux, all the impurities are collected in the form of a slag at the upper part of the molten metal, which may be in floating mode. So it can be removed with the help of this slag hole. Chimney or stack, the part is here. It is the uppermost part of the furnace. Exhaust gases can be removed by this chimney. So it is a construction of cupola furnace. It consists of shell, foundation, bottom door, tuyeres, wind box, charging door, tap hole, slag hole and chimney, and it is also known as a stack. So the exhaust gases which are removed from this chimney, they are sometimes also known as stack gases. Now let's see the operation of cupola furnace. So first stage or first step in operation is preparation of cupola. When cupola furnace is used, it may contain at the bottom part some impurities or sediments. So this door is dropped down and cleaning is done inside the furnace. If any fire bricks or refractory lining is damaged, then it may be repaired. Next step is lighting the fire. Now for this purpose, initially small soft wooden pieces are used which are ignited, and when they are ignited well, the coke is charged above this already burning wooden pieces. So by that way the coke can be fired properly. Charging of cupola is done from this charging door. So alternate layer of metal, flux and coke is charged inside the cupola furnace. The flux which is used in most general cases is limestone, and it will act with the impurities, it will react with the impurities, and it will form a slag which can be removed from the slag hole. Melting. Now the charge has been done and there is sufficient temperature also is produced inside the furnace. So now melting action takes place and the metal which is melted drop down from the upper part to the lower part of the furnace, and all the molten metal is removed by this melting pot. Slagging and tapping. It is the operation which is carried out at this part of this furnace. So when molten metal is separated from this tapping hole, and as we can see the slag over the molten layer of a metal, we have to remove that slag from this slag hole, and as air blast is continuing, the melting process will be continuously taking place. So alternatively slagging and tapping is done by this slag hole and tapping hole, and all the molten metal is collected. Now let's see the different zones and which are the chemical reactions takes place in these zones. So first zone is known as a well. It is shown here. It is sort of well in which the molten metal is collected. Then combustion or oxidation zone. This zone is located above these tuyeres. So in combustion zone, actual combustion takes place where carbon is oxidized with the help of the oxygen from the air, and it will produce carbon dioxide, and large amount of heat will be produced which will be distributed to the other zones of this furnace. So it is a reaction in which heat is liberated. If the scrap or the raw material consists of manganese, then manganese may be also oxidized, or if it contains silicon, then it will be also oxidized, and large amount of heat is liberated. So oxidation takes place in an oxidation zone. Above oxidation zone there is a reduction zone. This zone is a reduction zone. From the uppermost part of this charging section, reduction zone is shown here. So up to melting zone, it is a reduction zone. So here the heat which was produced in a oxidation zone is used, and again reduction process takes place. Actually it is helpful to prevent the metal from the oxidation. So the CO2 which was produced here, again it will make chemical reaction with the carbon of the coke and it will produce carbon monoxide, but as heat is used here, temperature will drop down. Then it is a melting zone in which actual melting takes place. The metal is melted and all the molten metal is dropped down to this well zone, and from the well it will be removed. In melting zone, the ferrous will react with the carbon monoxide, so it will form ferrous carbide and CO2. And last zone is stag zone, from where stag gases are removed or stag gases are exhausted to the atmosphere. Thank you for watching.